So in this problem, we need to verify that sine of 5x is given by the following trig expression. Let us begin. So we will start our problem from the left hand side. We will consider sine of 5x. However, we're going to break down 5x into two parts such that we have sine of 3x plus 2x. Now here we have a formula which is given by sine of the compound angle A plus B. Now that's given by sine of angle A times cosine of angle B added to cosine of angle A times sine of angle B. Now what we'll do here, we will consider A to be equivalent to 3x and B to be equivalent to 2x. So let's apply this formula. We should get sine 3x multiplied to cosine of 2x added to cosine of 3x times sine of 2x. Now sine 3x, cosine 3x, sine 2x and cosine 2x, these are the formula that are known. So let's note them down. So sine of 3x, that's given by 3 sine x minus 4 sine cubed x. Then we have sine of 2x. So sine of 2x is given by 2 times the product of sine x and cosine x. Next we have cosine of 3x. The cosine of 3x will be 4 times cosine cubed x minus 3 times cosine x. And we have cosine of 2x. Oh, here cosine of 2x has got 3 forms, but we will be using in this particular case the formula 2 times cosine squared x minus 1. So let's substitute all of these values into our form. So sine 3x will be replaced with 3 times sine x minus 4 sine cubed x whole multiplied to cosine of 2x. So we will use 2 times cosine squared x minus 1 in the place of cosine 2x. This will be added to cosine of 3x, so that's 4 times cosine cubed x minus 3 cosine x whole multiplied to sine 2x, so that will be 2 times sine of x times cosine of x. Okay, now what we'll do, we will expand them. Expanding gives us so 3 sine x times 2 cosine squared x, that will be 6 sine x multiplied to cosine squared x. Then we have 3 sine x multiplied to negative 1, giving us negative 3 sine x. Then we have negative 4 sine cubed x multiplied to 2 cosine squared x, so that will be negative 8 sine cubed x multiplied to cosine squared x. And then we have negative 4 sine cubed x multiplied to negative 1, making it positive 4 sine cubed x. Now coming to the product of the next two, we have 4 times cosine cubed x times 2 sine x, so that will become 8 cosine cubed x times sine x. And we also have another cosine x multiplied to it. This will become cosine x raised to the power of 4 minus 3 times 2, that will be 6. So we have 6 sine x, and cosine x is multiplied twice, we'll get cosine squared x. Fine. Now the first term and the last term cancels out, and let's rewrite the remaining terms. Now we have here is 8 cosine x raised to the power of 4 times sine x. However, we need only 5 cosine x raised to the power of 4 sine x, so we can split this into two parts to get 5 times cosine of x whole raised to the power of 4 times sine x. And we have 3 times cosine x raised to the power of 4 times sine x. Next, we need negative 10 cosine squared x sine cube x. So here we have a negative 8 cosine squared x sine cube x. So what we'll do, we will take negative 10 sine cubed x times cosine squared x. But we have exceeded negative 8 by 2, so we're going to add it. Plus 2, so we have plus 2 times sine cubed x times cosine squared x. And let's write down the remaining terms. So we have negative 3 sine x Then we have plus 4 sine cube x. So these are the remaining terms. Now, what we'll do, we will combine this with this, and this is going to become 5 cosine of x raised to the power of 4 times sine x. And then we have negative 10 sine cubed x times cosine squared x. And then we have the rest of the terms. So here we have positive 3 cosine x raised to the power of 4 times sine x. Then we have plus 2 sine cubed x times cosine squared x minus 3 sine x plus 4 sine cubed x. Now we don't have to worry about the first and the second term. Now what we'll do, we'll try to simplify the rest of the 4 terms. So let's write down the first 2 terms. So here in the third term, we have 3 cosine x raised to the power of 4. But what we can do, we can rewrite it as 3 times cosine squared x whole square multiplied to sine x. Then we have 2 times sine cubed x and multiplied to it as cosine squared x. But what we'll do, we'll convert this cosine squared function to the sine squared function as 1 minus sine squared x. And we have the remaining terms, negative 3 sine x plus 4 sine cubed x. The reason why we converted this cosine x raised to the power of 4 into cosine squared x whole square, because we can replace cosine squared x with 1 minus sine squared x. So here I have replaced the value of cosine squared x with 1 minus sine squared x. Then the next step, what we'll do, we'll expand this, and this should give us, so here we have expanded 1 minus sine squared x whole square to get 1 minus 2 sine squared x plus sine x raised to the power of 4. Also, I have multiplied 2 sine cubed x plus 1 minus sine squared x to get 2 sine cubed x minus 2 times sine x raised to the power of 5. Now we will multiply this 3 with each of the 3 terms within the parentheses, and that should give, so we have 3 multiplied to 1 times sine x, that gives us 3 sine x. 3 times negative 2 sine squared x times sine x gives us negative 6 sine cubed x. And we have positive 3 times sine x raised to the power of 4. Now here, we can see that some of the terms will get cancelled out. So positive 3 sine x and negative 3 sine x gets cancelled out. Then we have 4 sine cubed x plus 2 sine cubed x. That's positive 6 sine cubed x. That gets cancelled out with negative 6 sine cubed x. And finally, we get 5 cosine x raised to the power of 4 times sine x. That's the first term, minus the second term, which is negative, which is 10 sine cubed x times cosine squared x. And then we have 3 sine x raised to the power of 5 minus 2 sine x raised to the power of 5, giving us positive sine x raised to the power of 5. And this is going to be the expansion of sine 5x, and this is what we were needed to show. Hence, proof.